Hello.
जी सर.
Okay. Thanks to everybody. Good afternoon. Today we'll discuss an introduction to Fourier transform and integral transform. In previous lecture, we have studied about the Fourier series within 2 or 3 lectures. So today we'll actually start with Fourier transform and integral transform. Actually, Fourier transform is a types of integral transform. Now we'll discuss about the basic topics of Fourier transform and integral transform. Okay, first of all, what is Fourier transform? Uh, Actually, Fourier transform, the Fourier transform simply states that the non-periodic signals whose area under the curve is finite can also be represented into integral of the sine and cosine after being multiplied by a certain weight. That means we have to represent an integral form. You must know about what is integration. Especially we have to use to finding the area and volume of a curve, in enclosed curve, enclosed of a multiple curve. Then we have to, if you want to find out the area or volume, then we have to use integration. So the Fourier transform simply states that the non-periodic signals whose area under the curve is finite, and it can be also represented into integrals of the sine. Remember it. This is the main keyword: sines and cosines after being multiplied by a certain weight. This is the actually definition of Fourier transform. Now, actually, what is application of Fourier transform? Mainly application: the image compression, filtering, image analysis. This is the main 3 application of Fourier transform. Hmm. Now you have studied what is Fourier series. Now the Fourier series simply states that the periodic signals can be represented into sum of sines and cosines when multiplied with a certain weight. Okay, we have studied about this Fourier series and solved many real life examples connecting to Fourier series. Now, actually, what is the basic difference between Fourier transform and the Fourier series? The both Fourier series and Fourier transform are given by Fourier, Joseph Fourier. You must know the historical notes on Fourier. In our previous lecture, we have studied this. But the difference between them is Fourier series is applied to periodic signal and Fourier transform is applied for the non-periodic signals. So after a long time, we have understand that the Fourier series is applied for periodic signal and Fourier transform is applied for non-periodic signals. Remember it, these keywords: periodic signals and non-periodic signals. So non-periodic means you must know which is not periodic. That means doesn't uh, you must know what is period of a wave. So it non-periodic means which cannot that violate the periodic properties. So this is the basic difference between Fourier transform and Fourier series. Now Dirichlet condition, we have studied in Fourier series what is the Dirichlet condition, and using Dirichlet condition we have solved many examples. Actually, summarize of Dirichlet condition: signal should have finite number of maxima and minima over any finite number. You must know signal will be like this. Okay, signal, and there will be a finite number of maxima and minima over a finite number of signals. Okay, now signals should have number of discontinuities over any finite interval. You must know in any signal there will be not a may not be a continuous form of a function. So there will be a number of discontinuities over the whole signal at any interval. Signal should have absolutely integrable. You must another properties is the signal must be absolutely integrable. That means we will find an integration between a certain limits. These 3 conditions you have to remember, and this is called actually Dirichlet conditions. Now Fourier analysis of discrete time. Okay, frequency analysis of discrete time. This is synthetic equation, inverse transform, and this is the direct transform. Okay, before knowing this, we have to understand about the integral transform. What is integral transform? Because we are using integration in analysis equation, direct transform. This is the summation minus infinity to plus infinity xn e to the power minus j omega t omega n. Okay, then if we take a synthesis equation, this is the analysis equation using summation, and we can replace this summation into integration. So we must know about the what is integral equation. Now, what is integral transform? Integral transform are used in the solution of partial differential equation. Actually, you must know in everywhere wave equation is occurred in signal processing, in sound, when transferring the sound from one part to another part. So there is a wave equation. So in any wave equation, partial differential equation occurs. So the integral transform are used in the solution of a partial differential equation. That means integral equation transform is a tool for solving partial differential equation. The choice of a particular transform to be used for the solution of a differential equation depends upon the nature of the boundary condition of the equation and facility with the which the transform fs can be converted to give f of x. Okay, this is the actually Fourier transform, integral transform f of s, and this is the f of x is the main function, mother function. Now integral transform can be written as the integral transform f of s of a function f of x. Remember it, this capital F s is the integral transform of a function f of x with kernel k as x is defined as integral transform of f of x can be written as capital F as integration a to b, limit will be a to b, upper limit will be b and lower limit will be a, f of x k s x. This is the actually multiplied parameter s and x with the mother function, parent function f of x. So this integration is called the integral transform f of s. For example, there are many types of integral transform. There are actually about 7 types of integral transform here. And Fourier transform is one of them here. Okay, now Laplace transform, you have this in your syllabus. Laplace transform with kernel will be this function will be kernel function sx will be e to the power minus sx. Okay, Laplace transform will be like this, and Fourier complex transform will be e to the power isx, e to the power isx. This is the kernel e to the power isx. But for Laplace transform, the kernel will be e to the power minus sx, and for the Fourier will be isx. And for inverse formula will be f of x equals to like this. This is the inverse one. This is the main formula Fourier complex transform, and this is the inverse Fourier complex transform. And Fourier sine transform with kernel sin sx. Function will be what? Sin sx. Because this is the exponential form. You must know this exponential form can be written as sin x plus, cos x plus I sin sx. Cos sx, this equals to what? Cos sx plus I sin sx. So Fourier sine transform will be sin sx, function sin sx, and inverse will be like this. Then Fourier cosine transform will be cos sx. Kernel will be only cos sx. So Fourier cosine transform capital FCS. Okay, this will be can be written as 0 to infinity root over 2 by pi of x cos sx. This is actually formula for Fourier cosine transform with kernel this. Now Hankel transform, this will be the kernel for that. Okay, now Hilbert transform will be this like this, and Mellin transform with the kernel x to the power s minus 1. Just this is the will be multiplied with the parent function f of x, and integration will be 0 to infinity because it lies between 0 and infinity. So between these 7 integral transform, will study about the Fourier transform from here. So what is Fourier transform? You must know, actually I have defined this Fourier transform. Now there are continuous Fourier transform. Continuous means you must know in the whole curve there will be a continuous form will be happened within any interval. The starting point to end points, the whole curve will be continuous. Now the periodic and non-periodic, you must know we have to use periodic Fourier series for periodic function, and for non-periodic we have to use Fourier transform. Remember it. This is the basic difference between Fourier series and Fourier transform. So for continuous time, this is the first column, and for discrete time this, and for periodic we have to use Fourier series, and for periodic we have to discrete Fourier transform. Remember it. Now for aperiodic, continuous Fourier transform will be, and the Fourier transform will be for discrete way. Now actually we must know about the what is Fourier series, deal with the continuous time periodic signals and discrete frequency spectra. A periodic signal like this is the signal, and T, capital T is the period. These two what, one period, capital T, okay, capital T, and this is another period, capital T, and in along x-axis time T, and f of t will be the along y-axis. This is the imaginary axis. Okay, so we can find the Fourier series like this. Now two form of Fourier series you must know. We have studied about this in our previous lecture. Now I am skipping this. Now what will be the aperiodic signal? Aperiodic means what? Not periodic. Okay, aperiodic means what? Not periodic. Actually these types of signal, this is non-periodic. Remember it. All period are not equal. Okay, capital T is not equal in everywhere. Suppose from starting point to this is the capital T, but from this point to this will be not capital T, not periodic. This is why. So these types of signal is aperiodic or non-periodic signal. If capital T stands to infinity, then what will be happen? That means if period is infinite, then what will be happened in that case? So Fourier integral, actually continuous time Fourier transform, Fourier integral. Fourier integral, we have represented this in our integral transform. This is the main formula for Fourier transform, and from this transform the sign transform will be this. This Isx will be changed into sin Sx. Okay, and this 1 by root over twice pi will be becomes root over 2 by pi. Remember it, sin Sx. If we use cos here, then it will be Fourier cosine transform. So the Fourier complex transform with the kernel e to the power Isx can be written as a Fourier transform of f of x equals to f of s. This equals to 1 by root over twice pi, and integration will be minus infinity to plus infinity f of x, the kernel e to the power Isx. And if we want to find out the inverse formula for Fourier complex transform, then this f of x will be here. Okay, and this f of s will be there, and integration will be with respect to s because parameter changed. But here in the usual formula, integration will be with respect to x, but in inverse formula integration will be with respect to s parameter. Now if Fourier sine transform, this e to the power Isx will be changed to what? Sin Sx. Okay, and inverse will be f of x will be there and f of s will be here. Okay, but this integration will be with respect to x, but the inverse will be with integration will be with respect to s parameter s. Remember it. Here all are changed parameter, s parameter, and here x parameter. So similarly, for cosine transform, the kernel will be what? Cos sx. Sin sx will be cos sx for cosine transform. So same formula, just c suffix used for only to mean cosine transform of Fourier. So f of c, f of x, Fourier cosine transform, this read as Fourier cosine transform of f of x equals to Fourier cosine transform equals to root over 2 divided by 5, 0 to infinity f of x cos sx dx. Actually, this 0 to infinity in our main formula minus infinity to plus infinity, by using the properties of definite integral, you must know this minus infinity to plus infinity can be represented as 0 to infinity by multiplying with 2. So after multiplying with 2 here, this constant will be changed to root over 2 by 5. Okay. So the Fourier cosine transform, similarly, we can write 0 to infinity f of x cos sx dx. This is with respect to x. And the inverse will be what? This f of x will be equals to inverse Fourier cosine transform will be root over 2 by 5, 0 to infinity. And this will be come here. And cos sx same. And this dx will be changed to ds because this will be with respect to s parameter. Remember it. This formula we have to use in every higher of Fourier transform. So we must remember that the integral transform are used in solving partial differential equation with boundary conditions, because without boundary conditions, we cannot find out the exact solution. So within a boundary conditions, we can use integral transform for solving partial differential equations. Now, list formula of Fourier integrals. Actually, in Fourier transform, we have to solve different kinds of Fourier integrals involving these types of. So number one, Fourier integral for f of x is f of x equals to 1 by pi 0 to pi minus infinity to plus infinity f of t cos u t minus x du dt. This is actually double integral, multiple integral. So with respect to u and t. Okay, this is the u will be range what? 0 to infinity, and t will be range minus infinity to plus infinity. Now for Fourier sine will be what? Just sin ut and sin ut sin ux du dt. And for Fourier cosine will be what? F of t cos ut cos ux du dt. We have to remember this list of formula for Fourier integrals. And this is the for Fourier integrals. And this is for number two formula is will be for Fourier sine integral. Okay. And this is for Fourier cosine integral. We have to remember these three formula. Now, the Fourier integral theorem, it states that f of x equals to 1 by pi 0 to infinity minus infinity to plus infinity f of t cos u t minus x dt du. That means we are proving this first formula. Fourier integral for f of x equals to this. Fourier integral theorem. This is the statement. Fourier integral theorem. Now, to prove this theorem, we have to use the Fourier series. Now, we know that the Fourier series of a function f of x between this interval minus c to plus c is given by this. You must know from our previous lecture, f of x is the Fourier series equals to n naught by 2 plus summation n equals to 1 to infinity n cos n pi x by c plus summation n equals to 1 to infinity bn sin n pi x by c. This is the equation number 1. This is the formula for what? Fourier series within the interval minus c to plus c. Now, where n naught is the cos coefficient of Fourier series for n equals to 0. And n is the cos coefficient and bn is the sine coefficient, you must know, of the Fourier series. So, you must know this formula. This is the actually Euler's formula for finding Fourier series coefficients. N naught equals to 1 by c minus c to plus c f of t dt, and n is the cos coefficient will be cos coefficient of Fourier series n equals to what will be 1 by c minus c2 plus c f of t cos n pi t by t c dt. Here t is the time, and bn is the actually sine coefficient for Fourier series. So 1 by c minus c2 plus c f of t sine n phi t by c dt. Now substituting these all values a naught, n and bn to this equation 1. Now substituting these all coefficients of sine and cos in equation 1, we get actually a big equation like this. Okay, after substituting a naught values, and this is the n values, and this is the values of bn. Okay, so there is a summation and integration also, remember it. Now this can be written as 1 by twice c, and this is the integral limits minus c to plus c f of t dt. Okay, now plus summation n equals to 1 to infinity, and this is the 1 by c, and limit will be minus c, integral limit will be minus c to plus c f of t. Here f of t is the common from these two term, and summation n equals to 1 to infinity and 1 by c minus this integrals also common, that means dt is the common. Okay, from these two term, then we get cos n phi t by c cos n phi x by c plus sin n phi t by c plus into sin n phi x by c. You must understand here, just taking common f of t and dt. So with respect to t, the integration also common, and within third bracket we get this one after taking common. So this is a formula cos a cos b plus sin a sin b. Do you know this is the trigonometric formula? Which formula is the cos a minus b formula? Do you know? Cos a cos b plus sin a sin b. What is the formula? Cos a minus b. Cos a minus b equals to what? Cos a minus b what? Cos a cos b plus sin a sin b. This is the cos a minus b formula. So just using this formula, we get a simple form. So this 1 by 2 c minus c2 plus c f of t dt plus n equals to 1 to infinity 1 by c minus c2 plus c. This is the f of t, and cos this taking common n phi by c, we get only t minus x here, only t minus x. So after this line 1 by twice c minus c2 plus c f of t is common, okay, from these two term. So we get only 1 plus 2 into here 2 into n equals to, because 1 by 2 half is common, this is why you have to use another 2 here. Okay, if we multiply this, we get this whole line. So 1 plus 2 into n equals to 1 to infinity cos n phi by c t minus x dt. That means this integration with respect to t. Since the cosine function are even function, you must know cosine function is even function, because cos minus theta equals to what? Cos theta. You must know from our first lecture on Fourier series, the even definition of even function what? If f of minus theta, f of minus x equals to f of x, then it will be even function. So cos minus theta equals to cos theta. This is why it is even function. So we can easily write this expression 1 plus 2 summation n equals to 1 to infinity cos n phi by c t minus x, this second bracket function. Okay, this total function, this can be written as n equals to minus infinity to plus infinity cos n phi by c t minus x. Okay, because this is even function, this is why we can write 1 to infinity after multiplication 2. This is why we can write this one, this 2 for what? Minus infinity to plus infinity. Then 2 will be cancelled. Okay, then the series will be start from what? Cos n phi by c t minus x, because cos 0 equal to 1, you must know. Within minus infinity to plus infinity, there another term for n equals to 0. Okay, cos 0 equals to what? 1. So we get easily 1 after simplifying this. So n equals to minus infinity to plus infinity cos n phi by c t minus x. This series can be written as this. So this equation number 2 can reduces to f of x equals to 1 by twice c minus c to plus c integration f of t, this f of t, and this whole series can be written as like this. Okay, just minus infinity to plus infinity cos n phi by c t minus x. Remember it. So this can be written as 1 by twice pi minus c to c f of t this pi and this pi also cancelled. You remember it. Just we are arranging a series. Okay, 1 by twice pi minus c to c f of t pi by c summation minus infinity to plus infinity cos phi and phi by c t minus x. Okay, and this is the equation number 3. Now let us assume that c increases indefinitely. Okay, c increases indefinitely, so that we may write n phi by c equals to what? U, and pi by c equals to du. Okay, pi by c equals to du because it increases indefinitely. This assumption gives, after using this assumption, limit c tends to infinity, this series pi by c summation minus infinity to plus infinity cos and pi by c t minus x, because c increases what? Indefinitely means what? C is very large, that means c tends to infinity. Remember it. C increases indefinitely means what? C tends to infinity. Then this whole series can be converted to in this summation becomes integration minus infinity to plus infinity cos u, because n phi by c means what? U. And phi by c means what? U. Cos u t minus x, and as pi by c means what? This pi by c will become du. So this minus infinity to plus infinity can be written as 2 into 0 to infinity. Okay, so 0 to infinity cos u t minus x du. This is equation number 4. Now substituting uh, this one in equation 3 from 4. Okay, from substituting this one, these values. Okay, we can write f of x equals to 1 by twice pi minus c to plus c, this whole series can be written as like this. Okay, f of t 2 into 0 to infinity cos u t minus x du dt. That means f of x equals to 1 by pi, 2 cancel, 0 to infinity minus pi to minus infinity to plus infinity f of t cos u into t minus x du dt. This is the uh, in, uh, actually our statement, our required statement of Fourier integral theorem. A little bit large, but if you do practice, I hope everybody uh, can do this. Now we have to remember this. This is a formula for finding, for using the Fourier integral theorem. Okay, this is the statement. We have assumed that the following conditions here in on f of x defined in a single valued except a finite point minus c to plus c. F of x is periodic outside minus c to c with the periodic what? Twice c, because the limit is the interval is minus c to plus c. So total what will be? Twice is the period. So number 3 condition, f of x and f dash x, that means first derivative of f of x are sectionally continuous minus c to plus c, because in this is not continuous in everywhere, this was sectionally continuous. And minus infinity to plus infinity, absolute value of f of x converges, that means we have to find a limit for this integral, and f of x is absolutely integrable in minus infinity to plus infinity, and these 4 conditions satisfied by this statement of Fourier integral theorem. Remember it. So this is very important for you, the statement of Fourier integral theorem and proof of this theorem.
Thank
And
you.
boost issues for
Assalamu
you. Okay.
alaikum.
Okay, we have studied about what is Fourier transform, what is integral transform, what is the uses and application of Fourier transform and application and integral transform, and what's the basic difference between Fourier series and Fourier transform. This is very important for you. In Fourier series, we have to use in periodic signals or periodic wave, and in non-periodic signal, we have to use Fourier transform. Okay, thanks to everybody. Best wishes for you.